Tamarai Selvi is working as a professor in the Department of Computer Technology, MIT campus of Anna University, Chennai. She has over 30 years of teaching experience. Grid computing, cloud computing, and e-learning are her areas of interest. She has successfully completed 12 research projects funded by Government of India and Tamil Nadu state government. She has established Center for Advanced Computing Research and Education and acquired 1 patent and has filed for 3 more patents in her research area. She has presented over 110 papers in international conferences and published 45 papers in international journals. She has authored 5 books. The latest book is titled Mastering Cloud Computing, published by Morgan Goffman Publishers 2013.
Welcome back to the UGC lecture series on cloud computing. Then who are benefited by cloud? Collaborators. Suppose if you want to have the collaborative operation to be performed, because in industries everything is a teamwork. You cannot work in isolation. In today's context, collaborative applications are much more popular. The actual technology as an island is helpless. Everybody is to be collaborated, then only you can be successful. You can see the collaboration of so many IT companies, so that they are doing a wonderful applications. So, collaborators are very much benefited by cloud. Road warriors, a sales representative, he cannot carry the big computing machines wherever he goes. Simply he can have a small smartphone, just he can access the internet. Everything is happening at the back end. Back end computing is taking place in the cloud. He will be getting only the result. So, for the road warriors it is very much helpful. Cost conscious users, you are not going to use it for a permanent basis. In that case, just you rent the machine or memory, then you make use of it. Then cost departments, the cost of the actual applications used for the departments will also be lesser, and users with increasing needs. See, some of the work may be seasonal. For example, if you consider the single window system, during the admission time you need more computers. After 2 months period you do not want it. So, whenever there is a demand, whenever there is a season, during that period you may need more number of resources. For such things it is easier to go by cloud computing. Who should not use cloud computing? See, if you do not have the internet facility, you cannot make use of cloud. The connectivity is hopeless. You cannot guarantee for the 100% connectivity. You cannot do it. So, internet impaired people cannot make use of it. Offline workers, you are not at all connected with internet. You are in a very remote place where there is no signal reaching that place. In that case also you cannot. Offline workers cannot use the cloud. Security conscious, suppose you are going for a financial application. If somebody just hijacks the important vulnerable data, that is all, the entire business is gone. Somebody is simply having some intrusion and you are just damaging the application, you need not steal anything. For bank transaction, whenever you are withdrawing money or you are crediting something, during the transaction, if the application is simply disturbed, if it is intruded, then automatically this transaction gets spoiled. So, some of the security conscious applications cloud cannot be useful, and suppose you are having certain facilities created, you do not want to invest something more, it is working fantastically, then in that case I do not want to invest something else for the cloud. So, using only the existing applications, you need not go for cloud. Then what are the barriers, challenges, issues, limitations for using this cloud applications or web based applications? First thing is technical issue. We should be strong in the technical aspect and it should be proven for the particular application. So, technical issues to be fully clarified. Business model issues, the business model is less investment, more profit. If that is not tallied, you will not go for any business. Business people will not go for it. Then internet issues, the bandwidth is very poor. If you want to transfer some audio video file, if the bandwidth is very less and if it is flexible, you will not have the patience in listening to those things. Then security issues, already I discussed about the financial application. Compatibility issues, sometimes you are using one machine, whenever you access that compatibility is not there, then the users will not go for it. Social issues, some of the societal constraints, they do not want to share across internet, we want to have it in a close circle. Like that, there are certain sentiments, certain belief across the particular community, and it may create some issues. See, we say that AIDS cannot be revealed to all the people, some sensitive matters cannot be revealed. So, for some social issues you cannot go for cloud based application. And when you consider the essential cloud characteristics, we have seen lot of characteristics. Out of that, according to NIST, National Institute of Science and Technology, USA, they have given 5 essential cloud characteristics. First one is on demand self service. So, based on your demand, you can create your own service, and it should possess broad network access. The bandwidth should be high, that is the meaning of it, broad network access. Then resource pooling, you must be able to aggregate or pool so many resources independent of the location. One resource may be available in Singapore, another one may be available in Malaysia, another one may be available in India. Whatever may be the location, you must be able to aggregate all the resources together. Then rapid elasticity, elasticity, it is shrinking or expanding, but quickly you should be able to expand. If it takes 3 hours for expansion, nobody will go for that. Then measured service, you should be able to have the metering and billing. So, these are the characteristics which are important or essential. Then what are the various cloud service models? This is the important part. You would have heard about SaaS, PaaS, IaaS. These 3 names you would have had whenever you hear the name cloud service. It is very much important. Cloud means SaaS, PaaS, IaaS. These 3 are very much important. So, cloud software as a service, that is SaaS. This is the users providers applications over a network. Just you are developing one application, see Gmail, Google Map, I told you, these are all SaaS. Here the application is developed by Google, you cannot change any feature, just you can make use of it. The advantage is everybody can access it, you need not develop, but whatever limitations are there, you cannot overcome, that is SaaS. Only application is accessed as a web service, that is the meaning of SaaS, software as a service. Cloud platform as a service, PaaS. So, instead of the software, you can access a platform. What is a platform? You can deploy certain applications. It is possible to create some more applications in that platform. See, for example, NetBeans, it is an integrated development environment. There you can develop so many Java applications, web service applications. So, that is the platform which provides lot of facilities to create your own applications. That is called as platform. You can access the platform as a web service, that is what platform as a service. So, you are accessing a platform itself through your internet via your web browser. Cloud infrastructure as a service, infrastructure means a computer itself is accessed as a service. You are having one laptop, but you are trying to access another computer which is having high end memory and all. So, cloud service models mean SaaS, PaaS, IaaS. It is very much important to understand these 3 models, and we have got this diagram where you can easily differentiate. The package software is the conventional thing where you manage everything. Software as a service means managed by the developer or vendor. Platform as a service up to runtime managed by vendor. Application and data you are managing users. infrastructure as a service up to virtualization, vendors are managing OS, middleware, runtime, data, application, everything you are going to manage. So, now we have discussed about the various service models such as SaaS, PaaS and IaaS, which are considered to be the important cloud services. So, we have discussed what is cloud computing, how cloud computing was evolved, what are the various features, characteristics, issues, challenges of cloud computing, and what are the different service models we are having in cloud computing such as SaaS, PaaS, IaaS. So, we have seen the differences between software as a service, platform as a service, infrastructure as a service and packaged software, that is the conventional software normally we develop without using cloud computing concept. So, that is what is given there. The same concept has been depicted in the next diagram. This is also taken from the cloudsecurityalliance.org. Here you are having the SPI model. S stands for SaaS, P stands for PaaS, I stands for IaaS. So, you are having the same previous diagram being drawn in a different fashion. So, if you consider the cloud model, then you are having SaaS, PaaS and IaaS, that is what you have to remember. And this is the cloud architecture. Once if you understand what is the actual meaning of cloud, by having the different service models such as SaaS, PaaS, IaaS, we can also define the architecture which will be correlating with these service models. Now, if you see this diagram, here you are having the bottommost layer representing fabric. That fabric means that represents the hardware resources such as computing resources, various databases, various storage resources, network resources, all those things are called as fabric. Then you are having the unified resources. That unified resources means which resource you want to make use of for the particular purpose. So, a computing resource or any infrastructure which we consider from the fabric, that is called as unified resource. Then you are having the platform. Above the platform, it is possible to have the application. So, application is reflecting the software as a service, platform is reflecting platform as a service, unified resource reflects the infrastructure as a service, and in the data center you will be having the fabric or the hardware infrastructures available in the data center. Now, it is possible to define the cloud computing according to Ian Foster, who is considered to be the father of grid computing. He was the actual proprietor for this grid computing, we can say. Here, according to him, cloud computing is defined as a large scale distributed computing paradigm that is driven by economies of scale, in which a pool of abstracted, virtualized, dynamically scalable, managed computing power, storage, platforms and services are delivered on demand to external customers over the internet. In short, over the internet we access applications, platforms, infrastructure with scalability and virtualization in a dynamic manner for elasticity. So, that is the actual definition. So, different people have defined cloud computing by their own way, but everybody is having this cloud architecture. You will be having IaaS, PaaS, SaaS. So, that is the main thing you should understand. So, let us have a small break and we can continue later. Welcome back to this cloud computing lecture series. We are having the deployment models. Here private cloud, that private cloud means it is owned by the enterprises, it will be leased also. Then community cloud, a specific community, say for example, the physics community want to develop some application using this cloud, then they will be having the physics community cloud. Similarly, if you want to develop some financial application, for that financial business people can involve in that development. So, they will share the infrastructure for that specific community. Scientific community can share for their own applications. Then public cloud, it is sold to the public and it is a mega scale infrastructure. Anybody can access through the internet, that is public cloud. Then hybrid cloud, once if you combine private cloud with public cloud or private cloud with community cloud or private cloud, community cloud, public cloud, any combination, that is called as hybrid cloud. And we are having the SaaS maturity model. See, out of that SaaS, PaaS, IaaS, first let us discuss about the SaaS maturity model. It has been matured over a period of time. You are having 4 levels. First level is ad hoc or customized development of the application. Second one is configurable. Third one is configurable and multi-tenant. Third one is scalable, configurable, multi-tenant, efficient. These are the 4 maturity models. So, here you can see it. What is the actual meaning of these 4 models? Once if you consider that first model ad hoc or customized, you want to have 3 applications, then you will be creating one instance for one application, another instance for another application, another instance for another application. For example, you want to develop the application for payroll processing. For government sector, one application is completely developed. For private sector, another one is developed. For central government, another one is developed. So, you are having individual tenant or user accessing this particular application for government, this for private, this for central government. This is the first ad hoc model or custom model. Second one is configurable. In case of that configurable model, you are having 3 instances of the same application. You are not having different applications developed for different clients. Here for government, for private, for central government, all are one and the same software. Only thing is it is configured according to the user. If tenant 1 is coming, this software makes use of that specific part of it. Tenant 2 will be using that one, it will be the software will be configured based on the type of client. This is called as configured. Third one is multi-tenant. See, here you are having a single program that is suitable for private, government and central government, state government, central government and private. All of them are using the same instance. This is called as multi-tenant, having one software catering the needs of all the tenants. Here at least each one is having its own instances and that is configured, but here single instance, it is used by all the users. Then for scalability, it is not possible to have the single instance catering the needs of all those people. Suppose this instance can cater 100 users, this can cater 100 users, this can cater 100 users. Whenever the tenants are coming, the load balancer will balance and it will divert it to the appropriate server where the load is lesser. Suppose if it exceeds 300, another instance will be created and it will be used. So, this is known as scalability, multi-tenant at the same time scalability. So, these are the 4 types. So, in case of multi-tenancy, it is a architectural pattern. A single instance of the software is run on the service provider's infrastructure. Multiple clients access the same instance. In contrast to the multi-user model, multi-tenancy requires customizing the single instance according to the multifaceted requirements of many tenants. So, this is the actual trick. Multi-user means you will be having multiple user accessing the same application, but here automatically it will be customized according to the user. So, that is what in the scalable, configurable, multi-tenant, efficient you are using load balancer. in the configurable and multi-tenant you are using only a single instance. So, when the tenant 1 is accessing, automatically this will be configured to this one. The same software will be configured to this user according to tenant 2, according to this one it will be configured. So, they can access a single instance, that is multi-tenant. So, in cloud, software as a service is always implemented using multi-tenant. Nowadays, we are having the scalability by using load balancer also. So, the software as a service is having these 4 maturity models. Then who are the major players? I have just listed only a few: Google, Microsoft, Salesforce.com, 3Terra, Zogo, Amazon. Everybody is having major applications developed using SaaS. By having the internet, you are able to access all those things. So, in simple words, if you want to understand what is cloud computing, you are having user interface in your client machine through browser. You are having the internet connectivity. In the data center, you are having cloud providers for SaaS, PaaS and IaaS. See, SaaS means the various applications are available, you access through internet. PaaS means you are having PaaS available, you access through internet. IaaS means that virtual machine is available, you are able to access through internet. So, the cloud services are accessed in this way. It may be SaaS or PaaS or IaaS also. Now, how the data is transferred in cloud computing? You are having clients by having a laptop or by having PCs or iPad or some other device, any device you can have. Then you are having the internet, then you are having the cloud service providers. Actually, the providers are accessing the virtual computers which are available in the physical servers. In the physical server, if there is one server, it is possible to create 100 computers using virtual machine. 100 computers are created in the actual physical computer. That is why they are called as virtual computers. Now, let us assume how the data is transferred. See, all the data is brought to the cloud through internet, then it is brought to the cloud service providers. The cloud service providers are getting access to the virtual computers, then after processing the data is sent back to this cloud computing. So, this is the working principle of cloud. So, we are having the different types of services such as SaaS or PaaS or IaaS, everything is accessed in this way. So, the data transfer is happening in this way and you can immediately understand the security problem. Until networking is available, security will also be the problem forever. So, you can have the research activities to provide more security for so many cloud services. That is the biggest concern today, and CSI Cloud Security Alliance group is formed. They have given lot of requirements to be sorted out. Those who are interested can refer to the website and you can see the various developments in the security aspect. But cloud is having enormous opportunities for developing lot of applications because of its elasticity, scalability as well as economic use, and it is easy to use also. You need not worry about the developmental aspect, you should know how to make use of it. For example, if the car can be used only by the inventor of the car, it will not become popular. Car or bicycle or motorcycle, whatever it may be, somebody has invented. Mobile phone, only inventor can make use of it, means nobody will make use of it. That is why the cloud is also similar to that. You do not know how to develop the application, just you should know how to make use of it, then it will be useful for everyone. Cloud is having access through internet through various devices. See, it may be a laptop, iPad, Kindle device, it can be any smartphone, any mobile device. Like that, the cloud is connecting everything with the users, and by capturing the data, it is possible to develop so many applications. So, just we have discussed about the working principle of cloud computing so far. To recap, we have discussed about the need for cloud computing in the first session. Then what are the foundation required which are prerequisite for the cloud computing, and also we have discussed about what is cloud computing, how it is working, what are the service delivery models available such as SaaS, PaaS, IaaS, these things we have discussed. So, with this first part of the cloud computing is over. So, to summarize, we have discussed 3 cloud service models such as SaaS, PaaS and IaaS, that also we have discussed, and we have differentiated SaaS, PaaS and IaaS through the sketches, and the cloud architecture also we have discussed, and what are the different cloud deployment models such as private cloud, community cloud, public cloud and hybrid cloud, and we have discussed about the SaaS maturity model. For the purpose of understanding, the students may be able to answer the following questions. Compare the features of SaaS, PaaS and IaaS. Name the various levels of the SaaS maturity model. What is multi-tenant software as a service? How SaaS is made as scalable? So, if you are able to answer the questions, you may be able to revise the concepts which we have discussed in this episode. Thank you.